When we take action, those actions have results. In math, and particularly in the area related to math that we call statistics, we call those results outcomes. Before we act, we should always try to consider the entire set of outcomes. Now, a particular set of outcomes is called an event. Outcomes in a particular event are called favorable outcomes. Because when they happen, the event happens. Judging all of this, making decisions, particularly about taking risks, all falls under the heading of probability. Probability is an extremely important idea because, as you heard in the way I started this, probabilities have a whole lot to do with how we plan things. Every action, every situation you get into in life involves taking a risk. Indeed, some dealings with probability, some risk-taking, is absolutely required. Best example I can think of off the top of my head is life insurance. Think about it for a moment. When you buy life insurance, you pay some money to an insurance company. The insurance company then gives you a promise. During the term of the policy, if you die, they will pay a much larger amount to people that you designate. But if you don't die, the insurance company keeps your money. That's gambling. But it's gambling you can't afford not to do. When you marry, when you have children, when people are depending on you and your income, if you don't make that bet, you're being irresponsible. Because if you should die due to some unfortunate and unforeseen event, if you do die, you're leaving them high and dry without income that they were counting on, or without support or help from you. So this idea of probability, it isn't just for gambling, running off to a casino and taking ridiculous risks in a place where it's guaranteed that the outcome favors the other person. Fact of the matter is, the outcome favors the insurance company too. But the insurance company has competition for the right to make this bet with you. But think about what you're doing when you put that money down on the table to buy that contract with the insurance company. You're actually betting that you will die. And if you die, your contract becomes active and the people that you leave behind win. Now, that money isn't going to replace you. The people that you leave behind would rather have you. But you have to deal with the fact that there's a risk involved. This is just one example of many. Probability is a crucial aspect of planning any particular endeavor. You can't control every outcome. You can't control every event. But you have a responsibility to anybody involved with the project to act in such a way as to minimize risk while maximizing the possible rewards. Probability is a crucial tool in analyzing that. We characterize the events and outcomes that may result from our actions using a ratio. A ratio compares two numbers. The number of favorable outcomes, the number of outcomes in our particular event, is compared in a ratio to the number of possible outcomes. That's all the possible things you can think of that could result when you take a particular course of action. This ratio is called probability, and it's a crucial factor, as I said, in planning and judging and in managing risk. Let's take a look at a simple example. I always fight this battle. I'm kind of glad I'm the only person talking in this presentation at this moment. A lot of kids come to my classes believing that it's possible to have a dice. No, it's not. Dice is plural. The singular of dice is die. A single number cube, numbered 1 through 6 on its faces, is a die. Let's consider what happens when we roll a die. Well, as I said, we should consider all the possible outcomes. And all the possible outcomes are numerals showing up, representing the first 6 natural numbers. 1, 2, 3, 4, 5, 6. This is the set of all possible outcomes, and every event that could result is a subset of this set. One event might be rolling a multiple of 3. Well, if you roll a multiple of 3, there are 2 possible outcomes in our entire universe of outcomes, and those are 3 and 6. So the event of rolling a multiple of 3 is the set containing 3 and 6. As we said before, to calculate the probability, we have to calculate a ratio. The probability of rolling a multiple of 3 will be the number of ways to do that divided by the number of possible outcomes. Well, how many ways are there to roll a multiple of 3? We could roll 3, we could roll 6. There are 2. How many possible outcomes are there for rolling a die? There are 6. This ratio has to be reduced. The probability is 1 to 3. It is appropriate to speak of probabilities as fractions, so 1/3 is an appropriate way to speak of this. Do be careful. Every time you learn a new application of ratios, you should be careful to learn all the different ways that are appropriate for expressing it, because some are not like others, and it's important to know the language about what you're speaking. That way you can always command attention and be effective in helping to make decisions. As I said, probability is no joke. Probability is a crucial part of risk management, which is a crucial part of any leadership activity in any project that you undertake. Now, understand that this is an event that might happen or might not happen. There are 2 kinds of events you always have to be aware of. There are certain events and impossible events. A certain event might be the probability that we roll a natural number. Well, 1, 2, 3, 4, 5, and 6 are all natural numbers. The probability of rolling a natural number, the probability of any certain event, one that's absolutely going to happen, is 1. This is the most that probability can ever be. What about the probability of rolling a 7? Well, the die only has 6 faces, and they are numbered 1 through 6. It's impossible to roll a 7. How many ways are there to do it? There aren't any ways to do it. There are still 6 possible outcomes. 0 over 6 is 0. Probability will never be lower than 0. It'll always be from 0 to 1, including the endpoints. It is possible for an event to be certain, and it is possible for an event to be impossible. But most probabilities, and certainly most of the ones that have to be managed and understood, are between these two. When things are certain or impossible, there's not a whole lot of decision left to be made. Within a set of possible outcomes, creating an event, a set of outcomes, really creates 2 events. Here are our set of possible outcomes again for rolling the die. We've been talking about the possibility of rolling a multiple of 3. Let's say we're going to roll a number that's less than 3. So the probability that our roll is less than 3. Well, here are the 2 outcomes that can make that happen. There are still 6 possible outcomes. The probability of that happening is 1/3. But that creates another event, even though I haven't marked it yet. But notice when I create an event that includes 1 and 2 and not the others, I immediately create another event. Now, the event we're most concerned with is the one we've specified. But it's important to acknowledge there is another event, and it is the possibility that we might roll 3, 4, 5, or 6. Because that other event completes the allocation of every possible outcome, we call that second event the complement of the first event. Well, the complement of rolling a roll less than 3 is rolling a roll that is greater than or equal to 3. There are 4 ways to do that. There are still 6 possible outcomes. So the probability of our complement event is 2/3. Notice that because an event and its complement completely exhausts all of the outcomes in a set of outcomes, their probabilities together always have to add up to 1. The probability of any event added to the probability of its complement will always be 1. That's extremely useful, because sometimes the calculation of the probability of an event can be very complicated, while the probability of calculating the complement might be easy. In that situation, then, you can find the probability of an event by simply subtracting the probability of the complement from 1. Let me show you what I mean. Continuing with our example of rolling a die, the probability of rolling 2 is 1/6. There's one way to roll a 2, and there are 6 possible outcomes. The probability of not 2, now that we know the probability of 2, is actually pretty easy to find. Instead of the tiring and complicated activity of counting up all the other outcomes, we can simply take certainty and subtract the event we're talking about. 1/6 is the probability of rolling a 2. Remove that probability from certainty, and you have the complementary probability, which is 5/6. So we can use that property that the sum of those 2 probabilities has to be 1 to make it easier to find other probabilities. Now, this was kind of a silly example, but there are probabilities like that, and you'll encounter them if you study statistics at any great length, which I hope you will, where the calculation of the original event probability is very complex, but the complement is easy to calculate. When that happens, you're better off saving yourself all that work. The answer's just as right either way. Another popular way of expressing probability is to use odds. Odds are particularly popular when people are using ratios to describe the likelihood of sporting outcomes. And those sporting outcomes could be the roll of dice, the play at cards, the turn of a roulette wheel at a casino. You'll also see things expressed as odds quite frequently whenever you are watching a horse race on television. There are 4 races you might see on television in America each year: the Kentucky Derby, the Belmont, the Preakness, and the Breeders' Cup. And these are the premier races in the industry in America. And when these happen, to help people understand the likelihoods and how people are judging the horses, the people that are commenting on the race will put up a board listing the odds of each horse winning by listing the odds that the bookmakers at the track will pay for people who buy betting slips, usually $2 slips. What do you learn from that? Well, if you know how to interpret the odds, you can easily determine which horse is the favorite. Might help in your viewing pleasure. Frankly, betting on horse races is a traditional and very popular activity. Just remember one thing: if you decide to do any betting at all, don't bet any money that you really need. Only bet money that you can genuinely afford to lose, and most of the time, there isn't any such money. Anyway, calculating odds is based on exactly the same information as calculating probabilities. But the information is conveyed differently, otherwise we just call it all probability. There are two ways to express odds regarding a particular event. There are the odds in favor of the event, and there are the odds against the event. Once you know one, it's easy to find the other. The odds in favor of an event is a ratio. The numerator of the ratio is the number of favorable outcomes. The number of ways the event can actually happen. The denominator of this ratio is the number of unfavorable outcomes. The number of ways within the universe of possible outcomes that the event might fail to happen. So, for example, let's say you have a 20-horse race, but the bookmakers are placing 5-2 odds on a particular horse. That horse is probably the favorite, because they're saying, by placing those odds, that if the horse race were run 7 times, they would expect that particular horse to win 5 times. Well, when there are 20 horses in the race, that is a preposterous ratio. Bets are made and paid based on the odds against something happening. The odds against, simply the ratio of unfavorable outcomes to the number of favorable outcomes. So as I say that the odds for a horse at the track are 3-1, that means that if you pay a $2 ticket and the fee for establishing the bet, the bookie will pay you $6 if your horse wins, plus the $2 that you put into the bet originally. So that's how odds are used at the horse track. In general, odds are expressed frequently for elections, and there are odds for all other kinds of events. You can express the probabilities we've been working with our number cube in terms of odds just as easily. Just to complete the circle on the number cube examples, consider the odds in favor of a roll that is less than 3. Well, that's going to be the number of favorable outcomes divided by the number of unfavorable outcomes. And actually, you don't express odds that way. Odds are always read as a ratio. Probability can be expressed as a fraction, even as a percent or decimal. But odds are always expressed as ratios of whole numbers. So, the number of ways to roll less than 3 is 2. The number of ways to roll something other than what is less than 3 must then be 4, because there are 6 total possible outcomes. So the odds in favor of a roll being less than 3 are 1 to 2. And that is how it would be read. It could also be stated with a colon. You'll see odds expressed with a colon most often. The odds against will simply be the reciprocal of that. There are 4 ways not to roll less than 3, and 2 ways to do it. So the odds against that happening are 2-1. Hope that clears up some of the terminology surrounding probability and odds. Most courses in Pre-Algebra and Algebra 1 include some sections on probability. It's something that you need to be introduced to. It's the sort of thing that can pop up again in word problems regarding proportions. Probability is a wonderful application concept. And if you're going to get serious about leading organizations and managing projects, you're going to have to learn about insurance and risk, and therefore about probability. A lot of people like to use gambling examples to teach probability. That's fine. Don't let that suck you into the idea that gambling is a good idea. Most of the time it's not. However, as I mentioned with insurance, there are some gambles that it's irresponsible not to take. You should, if you marry, have children, have people that are depending on your income, you should make a bet with an insurance company that you're going to die during the term of a policy, and pay money to make sure that bet happens. And then, don't count it as money lost if you don't die. Remember that what you've done is you've managed risk. If you had died during that time, it would have taken care of the people that you care most about. So, it's really important to understand this probability stuff. When you come across questions that give you trouble about probability, odds, and risk, please don't hesitate. Go to my blog, drop a question on me through my email link, and I'll be happy to post an anonymous response, a response where you'll be anonymous, I won't be, that explains your problem as clearly and as concisely as I can.